Hey, this is Don from Padlock Technologies again with another video. This video is going to be in a response to something I said in the last video about building AI-ready networks. If you haven't seen that video, I'm going to put a card over, it's probably going to be over here somewhere, like in this section of the video. Um, and that will give you a little high level overview of building AI networks. Now, the thing that I'm going to be answering is spine leaf architecture versus rail optimized architecture for the GPU backend. If you don't know what the GPU backend is, again, watch the video I just did on building AI data centers, and that'll give you a high level overview of the three networks that are usually in AI data centers, right? But we're going to talk about rail optimized versus spine leaf. So if you ever worked in a data center network, you should know what a cross fabric is, which is a spine leaf fabric. Now, when it comes to the GPU backend, you got to be careful with that network, right? So let's start with the traditional. So we're going to go with traditional spine leaf. All right, spine leaf architecture. So pretty much it's going to look like spine, and then we got the leaf here, right? We got, let's say, 3 leaves. And we connect them this way, and we're done, right? So you could typically do this in any data center. You use whatever ACI, you can use Nexus dashboards, you can do it manually. Now, the problem with this design for GPUs or the GPU backend, as I'm about to show you, that you can do it, but that does introduce some more latency in the equation. So if you don't know, these GPU servers will have, 4 GPUs in it, 8 GPUs in it, depending on what you get. So let's just say you got GPU, GPU, GPU. I'll just use 3 for right now. So these are just hypothetically, these are the GPUs, and then we're going to put the NICs that they're assigned to. So each GPU is going to have its own NIC, right? And this is where RDMA, but if we're talking about non-InfiniBand networks, then we're talking about Rocky V2, which is RDMA over converged infrastructure, or converged Ethernet, right? Version 2, which is the IP version. Version 1 was a straight Ethernet. They just took off the InfiniBand stuff header and then just put an Ethernet header on it with the FCS on the end. But in this design, the NIC, each NIC would go to its respective leaf switch. And that's what it would normally look like. Now, let's say you were doing some training or tuning. We're not going to say production network yet, inference network or anything like that. Let's say just training for now. Pretty small design. Now, the problem with this is if you use up all the bandwidth of this, or not bandwidth, all the GPU or compute in this server, so you now need to use another GPU, well, you're now going to have to go, and this is going to be the data plane. You'll have to go up to the leaf switch, then to the spine switch, down to another leaf switch, down to this GPU here. Let's say that's the GPU you want to use. Well, as you can see, you now have to go over this switch, this switch, this switch. That's technically 3 hops. Technically, it's 2 because you're going to go from leaf switch, the spine, to the other leaf. But I'm talking about from the GPU server's perspective. You're going to go to the top of rack switch, or the top of rack switch, whatever. Then you're going to go to the spine switch. Then you're going to go to the other leaf switch, and then down to GPU that you need, right? You can still do this in normal design. There's a lot of people that run spine and leaf, but it's not as optimized as rail optimized design because you're going to put a lot of pressure in this area. So the spine, leaf to spine, is going to be a lot of traffic there, right? So just a lot of traffic, right, for inter GPU communication, right? And what inter GPU communication means is the GPU is not in the box. GPU to GPU within the same box is intra, GPU to GPU on another server is intercommunication. And this is what we're really talking about here. So you're going to put a lot of pressure on the spine and leaf because all that intercommunication or inter GPU communication has to go through spine and leaf architecture, right? Now, what's rail optimized? So let's open this up. Let's go to rail optimized. Rail optimized. So rail optimized, same architecture. So we have spine, spine. That's a super big spine. I don't know why I drew that big. And we have leaf, 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 same connection type. Okay. But this time we'll have the same servers. I will need to erase this because I wanted the G. That is definitely not the eraser. Come on, dude. So we'll keep yellow. We'll have GPU, 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 and then I'll use green for this server over here. GPU, GPU, GPU. And then finally, we'll have other GPU server, GPU, GPU, GPU. Right? Like I said before, Nick, 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 Nick. Now, Rail Optimize works completely different. So I'm going to use some different coloring here. So we have Nick 1, or we'll say Nick 1 is going to Leaf 1. Nick 1 on GPU server 2 goes to Leaf 1. Nick 1 on GPU server 3 goes to Leaf 1. So now we got Nick 2, Nick 2, Nick 2. And then finally, we have Nick 3. Actually, sorry. Nick 3, Nick 3, and Nick 3. Hopefully I can erase this one right here. Yeah. Okay. So as you can see here, this is a rail optimized design. And what they call rails is this here. This would technically be rail switches. Usually I just call them rail. This is rail 1, rail 2, rail 3. Okay. Still a leaf switch. They just call them rails and rail optimized. So what is the beauty of this compared to spine and leaf? Because that's the question that needs to be answered. Well, as you can see from a connection standpoint, all inter GPU communication never is technically local, right? It's technically local to the box from the box's perspective, from the GPU service perspective, because they're attached to every last one of the every switch, right? So it never actually has to go. Remember in the last picture, we had a problem with a lot of traffic here, right? So traffic rarely goes up to the spine. So traffic rarely, in this example, never goes to spine. Rarely slash never utilizes the spine. Right? So that means you're not introducing a lot of latency in this design, which makes your operations technically your compute operates a lot faster because it never has to go to the spine, back to a leaf, and down. So you're not introducing those little latency, and in AI, latency is a big thing, right? Especially with RDMA, you don't want to drop packets and stuff like that, right? Because you can bring down the entire system. So in most CVDs or JVDs for Juniper folks, they're going to say, hey, use a rail optimized design. Because if I do have to go to, let's say, I use up all the GPUs in this box here, and I want to use this GPU here for more compute. Well, all I have to do, I go up to rail number 1 from a data plane perspective, and then I go right to GPU 2. Now, remember in the other design, I had to go up to leaf 1 to spine 1 to leaf 2 to server. In this one, I go up to leaf or rail 1 and then directly to GPU. So I'm reducing the latency, which is increasing the performance of my AI cluster. So that is the difference between spine leaf architecture, normal spine and leaf architecture for AI GPU backend, and rail optimized architecture for GPU backend, right? Now, your storage backend and your front end could be just normal spine leaf, right? But in the AI GPU backend, which is your NVIDIA servers and stuff like that, or I think UCS does have its own version as well. But the GPU backend, you want to go with Rail Optimize if you can. All right. Because that's going to reduce the latency and increase the performance of your AI cluster. This is Don from Padlock Technologies again. Hopefully that cleared up what I meant in the other video about spine leaf on the GPU backend versus Rail Optimize. So hopefully that cleared that up. Don't forget to share, comment, like, and subscribe. If you got any more questions about certain technology, like I said before, I don't know everything, but I do know a lot. There's going to be a video bumper at the end where you can send some requests, and I'll be doing a video response if I can answer that question. If not, I can point you in the right direction, maybe to get you the answer. But if I can answer it, I'll do it in the video response. Don from Padlock Technologies again. Thank you and have a nice day.